Hey there, Python programmers. In today's video on class syntax, we're going to talk about getters and setters, and they really are very important to properly implementing object-oriented programming, which is really, again, programming using classes. Two rules we're going to talk about today are encapsulation and abstraction. So encapsulation means we should kind of hide the data and control how our users are allowed to access it. And really, this is the data in our cat class, the attributes or variables we've set up to store information. Right now, and in the past videos, we've done a very OOP, object-oriented programming approach, because we've directly accessed attributes. And this is something that Python unfortunately does allow us to do. So if we look just real quickly here, I'm giving an example. Print blue. Give it a run. And we see that, hey, we can directly access print blues.name. We can even set it equal to something new, and that's actually a permanent change. Again, it would be great if Python didn't let us do this. Unfortunately, it does. So we have some conventions to fix this. The first thing we're going to do is put an underscore in front of each one of these variables. Now, this is a convention in Python. What it tells other programmers is, hey, I would love if these attributes could be private. Again, we can't make them private, so we could still do exactly what we did down here. We just would have to change the values to blue underscore name. Very much like capital case letters for constant variables, or even the CLS we used right here for classes. It's a convention. And again, if you want other Python programmers to understand what you're doing, you should follow it. So how should we interact with these? Well, the only way we should interact with an attribute or variable or our data in a class is to use a method to do so. And this is where our getters and setters come in. Now you're going to have to stick with me on this one because the getters don't look at all fantastic. It just feels like more work. The real power of what we're going to do comes with the setters. But in order to have a setter, you also have to have a getter. So again, we're going to go through that. Let's start off with a getter or retrieving value. So we have a decorator called @property. And then after that, it is very important what we name this function. We need to name the method, sorry, or function, but we need to name the method what we want to use to call it. So we're going to call this name. Now, at this point, very similar to any of our other methods, it is an instance method, so it needs to take self. Usually with a getter, we do not have any other value because all we want to return is self dot underscore name. Cool. So let's go ahead and save this. And then what we're going to do now is let's just run this one. Oh, and my unfortunate problem is that we do kind of don't have all the abilities we need yet. We're getting an issue with color. Let's just quickly change some of these to underscores for the short term, because again, we will be able to change this back shortly. There we go. And you see, we can still print out blue. So technically, what this @property did is said, hey, I'm going to let you call this method without having to invoke it. That's ultimately what we did by saying blue.name. It's invoking that method. It's getting the value that we're storing in blue underscore dot name for us, because again, that's what it's supposed to return. So that's why we do end up seeing blue's name. And again, that's why it's so important to call this name, because all the @property is doing is saying, hey, you don't need parentheses to invoke this. Basically, again, remember if name was a method, we'd need those parentheses to invoke it. So that is what that @property is doing. And we do not need to change it inside of our function, our methods inside of our class, because now if we call self.name here, well, it's just going to go use the name function and return the value of self.underscore name. So while I had to do that with color down here, because again, we don't have a getter for color yet, we might add one. If a cat's color probably shouldn't change. So again, you could change a name. We certainly could change an age. We're going to set up getters and setters for those. If you're not going to ever change it, there's probably not a need to do so. So anyway, here is our getter. Now let's go ahead and do our setter, because again, that's really where the power comes in. So what we need to do here is at name.setter. And again, you have to be using the name to associate it with this property. And then for a setter, again, this is an instance method, so we're going to need self. You're pretty much always going to want to have a second variable because, again, we're making this function to change. The whole goal of this function is to change Blue's name to something else. Oops. So you need a decorator, but then you also do need to call the function the exact same thing. So again, we have to have both of these methods called name. Python's going to be in charge of which one it uses dependent on what we do. Real simply, what we could do is just say self dot underscore name now equals new name. Control this. Now, what this is going to allow us to do is we're now going to be able to do this functionality again as well. So what happens, or really what this at name setter is doing is saying, hey, when I invoke this function, I don't need to use parentheses, kind of like our getter. But what I do need to do is use the equal sign to assign what new value I want to have. So before, we would have to do something like, well, basically the same thing. But what it is really doing now behind the scenes is more or less we're doing this, but our decorator, that at named setter, is allowing us to, instead of invoking it and passing in the new value, we get to do exactly what we're doing above. So this is a lot of work to basically do something we were already doing, but we're not quite done yet because we can do way more with this setter function. We can add in some validations, and that's what I really like. So if the length of new name, I'm going to say is greater than 15, maybe. Like, again, this is a judgment call, but we can now actually say something like, hey, that's too long of a name. Cool. And then what we can do is we'll now throw in an else case. And this will now allow us to have a little bit of validation with our name. So if I say not blueberry the silly kitty, because that's kind of too long for a name, right? That doesn't just roll off the tongue when you're calling that cat. Let's give it a run. And hey, we got the information of that's too long a name for cat. What that also did is not change his Blue's name. So again, a little bit of validation. We now have a little control over what a user is going to set names equal to. And that's kind of important. Let's go ahead and just do this again for age, because it's going to be important to change the cat's age over time. Obviously, they do get older. And for a little extra practice, let's go ahead and do it for this one. So at property again, and then we need to do def age. Again, that has to be what we name this is how we are going to get that value down here. So the naming is rather important for this to work. And we want to remember for a getter, very simple. You're just returning self dot underscore age. Again, all this does is means when you want age or when you're recalling or getting the age value, it's going to go ahead and collect it from here. But again, the method is doing this work and interacting with the attribute. You are not directly modifying that. And that's really what we're working on here. Let's go ahead and define the setter while we're at it. So we do age setter, because again, we can have multiple setters as we're seeing. So having whatever other method or the getter is associated by calling it the same thing here. And then we want to do def age again. This one needs to be self, and then similar to before, new age. And we can again do a little more error validation. So let's say if new age is greater than, I believe on record 38 is the oldest age for a cat. So like again, can't have a cat older than that. We'll do that's too old of an age for a cat. And this is human years, not people years. For this, we could add an else if. Why not? Maybe have a lower bound, new age. How about is less than 0? That feels right, right? A cat shouldn't have a negative age. Print cats. Yes. Boom. And again, person, we are not going to set the name. If we pass those two validations, let's do an else case where we're going to say self underscore age now equals the new age value. Cool. Let's go ahead and mess around with Blue's age a little bit first. I'll comment these out for now. Let's print blues.age. And then let's change it. Let's try to change it a couple times, right? So blue.age equals 42, 43, blue's real old. Blue.age equals -1. And then let's set it just a year older. Blue.age equals 10. And we'll print out blue.age. Cool. Save it. Let's give it a run. Oh, sorry. We have an error right here in our age setter. Age 0, less than 0. I forgot the other side of that comparison. Here we go. And now we're going to get our feedback. We tried to set an age to too high value. We're being told that. We tried to set it to a negative. We're getting our validating feedback there. And then we correctly set. Really, really powerful. Again, if it's an attribute that's going to need to be changed, you really should do it like this. Now, one caveat I'm just going to mention because we're making a couple games like Wordle, Tic-Tac-Toe. Those are class-based games. I have not bothered to do that with them, but there's a real good reason. Those games are not something we interact with in this way at all, right? We don't directly, if we're playing Wordle, set next guess equal to a value. We have automated it so we have an input prompt, and those input prompts are absolutely the only way a user is interacting with those games. So there's really no reason to put this in because again, we have methods that are calling other methods or getting the attributes, but in no time is a user directly setting them. So again, this is really only when you have a class or an instance that's going to live a while and need multiple interactions would you want to do this stuff. Hope you found this video useful. And again, we're going to have one or two more on classes. Keep programming, Python programmers, and I'll see you in the next video.